All right. So, as mentioned previously, I'm going to talk about Android today and Android development. And I'm doing this for a few reasons. One, just because we've been doing Java, we've been working in Eclipse, we've been using Swing and Window Builder. Doing Android development is very similar to this. You usually work in Java. You use Android Studio, which is plays a similar role to what Eclipse has been doing for us, except it's built on IntelliJ. And let's just make a drag and drop graphical interface and then connect events to code, right, and tie it all together. So I want to just sort of present this as an alternative, view of the same kinds of things we've been doing in a different context. So that's one reason. Second reason is that if you're interested in doing Android development or mobile development in general, it can be a bit of a steep learning curve in the beginning, right? And I think I can help you get through some of the steeper parts of it with a little bit of intro. So this will be a one class overview. It's not going to go very deep. But I'll try to get you through some of the pitfalls that seem to come up when people start doing this. Another reason for talking about this is just that Android is a very different kind of operating system. It's not at all like Linux or Windows. In particular, Linux, you type a program name and it starts to execute, and at some point the program does a return from main and the program exits. And that's not at all what happens on Android. Lots of things start executing when the system boots, and when you exit an app and you go back to the home screen, the app does not close down and go away automatically. It may get disposed of later, but the whole life cycle of an application is very different from the life cycle of a program, which is basically, start the program and it's running. When the program exits, it's done. The other thing is, mobile development is fun. Android phones are pretty affordable. You can buy a cheapie for $30 or $40, and write applications for it. And if it has, an accelerometer inside, you can use that. If it has a GPS, you can use that. Even if you don't put a mobile plan on it, they're fantastic devices. They almost always support Wi-Fi, so if you're near a hotspot, you can use it and be online and browse and all that kind of stuff. But even as just a totally self-contained unit, right, these are phenomenal devices. They pack so much power. I had a friend a number of years ago. He was working on this long-term project to make a solar-powered plane that would glide all the way around the Earth. He wanted to circumnavigate, and it would, gain elevation during the day under sunlight, and then it would slowly coast down and lose elevation at night, and so on. And over time, he kept refining the design, but cell phones also kept improving, and at some point he realized what he was basically designing was a flying cell phone, and that one of these handheld units did everything that he needed to do, radio communication and navigation and acceleration detection and so on. So they're fun tools to be able to play with. You can use them for lots of things. You can use them as control systems, and lots of things other than a simple phone. So Android Studio has its own development environment. So if you just Google Android Studio, you'll see developer Android.com. That's the main site we're interested in, okay? And if you just click on download, I'm on a Linux system right now, so it'll pop me to the Linux download. And if I click on this, I'll pull down about a gigabyte worth of stuff, and that's my whole Android Studio. So a number of years ago, Android development was done under Eclipse, and you would download plugins that were specific to Android. That was pretty slow and maybe kind of buggy, and so Android development has moved to Android Studio, which is really built on top of IntelliJ. So what we're going to be doing today is basically working in IntelliJ, which is a whole topic in itself. One thing I want to mention up here, Kotlin. Kotlin is another language that you can use for Android development. Okay, so how does this work? Well, Android is basically Java, right? All the code that we're going to be developing today for Android apps is going to be written in Java. But Java, remember, runs on this virtual machine called the JVM, the Java Virtual Machine. Well, Kotlin is another language that was written that runs on the JVM. So it's a second language that can be compiled down to bytecode that will execute on the same Java virtual machine that runs Java, but it's a different language. It handles declaration of variables differently. It has a bit of duck typing where you don't necessarily have to declare variables if it's clear what they are. And yeah, so Kotlin takes care of a lot of stuff, as somebody's pointing out in the comments. It's becoming, to some degree, more the language of choice for Android development. And if you know Java, you can do Kotlin. If you know Kotlin, you can probably do Java. It's syntactic differences, and you have to be flexible. But it's another option, and a lot of resources that you find online when you're looking for code snippets, they'll actually give you a choice. Do you want to see Java or Kotlin? So we'll stick with Java, and I've already downloaded this package and I've already installed it. Now for Linux, there's not much of an install. It's really just dumping everything into an area. And I have a symbolic link set up. And the way I run this is just by running studio.sh. It's a bourne shell script, right? It's just a shell script. It's got Zenity that it uses for some stuff, and KDialog and so on. And this is just the wrapper around the binaries that'll be used to check what version of Java we're running, make sure that the Java development kit, the JDK, is in place, and a few other things. And it's just wrapper, right? And then IntelliJ down here. So to run this stuff, I just have to say studio, and I'll just run it in the background. And we get a nice fancy splash screen. And let's say start a new Android project. Okay, first thing we're going to do is we're going to pick a template. And we have options, okay? I'm going to develop for phone and tablet, but we could develop for, a watch, or a TV, or your car, or I don't know what Android things are, but I guess other. We're going to develop for phone in particular, and I'm just going to do an empty activity. Okay, we can you do a full screen, we can have something that's, geared towards doing something with maps and so on. Empty activity is kind of the sweet spot. Not too much code, but it's got a little bit to get us started. So we'll do that, and I will call this something like I don't know, call it ABC123, because I want it to show up in the beginning of my list of applications. I went through that a little too quickly. There was another thing on the bottom that I should have mentioned, which said, what version of the API do you want to use? And I think I picked the version corresponding to Oreo 8, which is 26. Android's continually upgrading. If you have an Android phone, periodically you get an update notice, and it bumps up the version of the operating system that you have. And when you write an application, you can target a particular operating system level. So if you target the latest and greatest, it's probably only going to work on some devices. If you target a lower version, then it'll work on more devices, but it may not use the latest and greatest features. So it's Oreo 8 seems to be kind of a nice sweet spot. Okay, now when I started running this, the following happened. Hold on a second and I will show you. So when I started running this, here's what happened on my phone. So I have my phone connected through a USB-C cable into my laptop, and it brought up this message saying, do you want to allow USB debugging? Alright, so we can develop on a virtual Android device, or if you have an actual physical device, you can use that. I think it timed out on me. Anyway, there's some steps that you need to apply. Oh, I just disconnected Zoom. That's why. There's some steps that you need to go through to be able to actually use your phone for development. And I'm not going to go through those, but you can find them online. It's this weird thing where you go into your settings and you go to one particular item and you tap on it like 7 times or something. And after you do that, you become a developer. And so there's a few things like that. And one of the things you have to do is you have to give permission to be able to do debugging on your device. So we'll mostly work with the simulation today, but we'll put a few things on the phone also. All right, so here's a totally generic, haven't done anything yet application. This is the boilerplate stuff that gets created for us, and there's actually a lot of stuff here. There's our Java file itself, which is this main activity. There's things called a manifest, and there's resources, there's layout resources, and so on. All this stuff got created for us. Okay, I'm just going to go ahead and click this run button, and what I'm going to do is try to run this on an emulator. So if I click here, I can say let's open the Android Virtual Device Manager, and these are different virtual devices, emulated phones basically, that I've created. So we can create a new one, and we can say I want to create a Pixel XL, right? Or I want to target a Square smartwatch, right? So I've already got Pixel 3 running API version 28, okay, which is Android 9. And I'm going to start that and dump my application onto it by hitting this green arrow button. Okay, this will boot up a virtual phone like this. I'm going to get rid of this thing. All right, and there's my application. There's the name of it, ABC123, and it says Hello World. Okay, that's all that this program does. So let me go back home and let me get rid of this thing. All right, and this is a pretty nice simulator, right? So I can click on Chrome and bring up a Chrome browser, and I can put in a URL, and there's a web browser, and I can bring up a syllabi for our course, and so on. So it's if you don't have an Android device, it's going crazy, man. If you don't have an Android device, you can use the simulator. One word of warning: this virtual device works really well on Linux. In my experience, and a student just confirmed this earlier today, under Windows it seems to be a fair bit slower. Where you'll click on something, it'll take a long time to respond, and so on. So you may want to actually use a physical device, but Linux seems to work well. I'm not going to update Google Play. All right, so and if I go in here and look at all my apps, there's ABC123. I can drop that onto my background, and then if I just click it, it'll go ahead and run my app again. All right, so let's do some stuff. First of all, I'm going to close out this thing that says activity main.xml. That's not going to do us any good today. But down here under resources, I'm going to open up the layout, and I'm going to find this activity main.xml. I'm going to double click that. This is the thing that we were using in Window Builder to design our GUIs. So this is a graphical representation of what our app is going to look like, and you can see, there's a box in the middle that says Hello World, and if I click on that, I can go over to the text field and I can change this to ha ha ha. And now if I push this onto my phone, it'll say ha ha ha. All right, this text view, it's like a text field. I can move around. I can put this into the upper right corner, and now if I run this on my device, my ha 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 is up there. Alright, so fairly intuitive until you try to do anything else. Okay, so let's take a button and let's drop this button down here. So I'll drag a button down here into the middle, and I will change the text on that button to go. And I'll run my app and put it on my phone, and guess what? My go button is up in the upper left corner instead of the middle where I told it to be. Okay, this is like pitfall number 17 or something. And if you look here, there's a little exclamation mark that's hard to make it persist the message, but it's telling me that this button is unconstrained. My ha 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 has these little springs attached to the end of it that connect it to the edges of my phone. My go button does not. Okay, not horizontally constrained, not vertically constrained, and if something isn't constrained, it gets placed in the upper left corner because that's convenient. So I'm just going to grab each of those, and I'm going to click and hold and drag and let go when I get up to the top. And so now I can control the placement of this thing, and these springs basically hold it in place. Alright, so that'll anchor it up down, but it still comes out to the left. Right, so you got to, well, I don't know if you have to, but it's helpful to anchor all four of these connection points. There we go. And now, I can say, okay, let's go right here, right down below my ha ha ha. And if I run that, it should come out right about here. Alright, so that's useful to know, and it'll kind of be a real pain if you don't know. You have to put those arrows in. And you can do this more intelligently than I'm doing here, right? For example, I could anchor this to the left side of my ha ha ha, and I could anchor the right side of ha 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 to the right edge. And the idea is, this application you develop should work on lots of different devices. Shouldn't just be a Pixel 3 with these particular dimensions. So what if my screen is suddenly very wide, right? I'd like to have these things move around in a way and maintain their relative placement to each other and so on. So that's what all of this layout manager stuff can do. But we're not going to mess with that. We're just doing basic layout here. Okay. So I'm going to put my ha-ha down below here. And let's do something when we click this button. Okay. So I've got two main things here. I've got my my layout, and then I've got my Java code. Okay, so I'm going to write a method in here, and it's going to be public void. I'm going to call it my go button, and it's going to take an argument of type view. I'm going to spell public right. And then what I'm going to do in here is, whatever I want to do. Button has been clicked. All right. So this is not compiling automatically the way that that it does in Eclipse. So I'm going to go ahead and build, and it'll tell me that view is undeclared, so I have to import that class. So that'll import android.view.view. Okay. There's lots of features to IntelliJ, right? For example, being able to collapse sections of code like that, or collapse this whole method and so on. I'm not going to talk about most of that. Honestly, I don't know most of what IntelliJ can do. I've learned enough to keep it from interfering with my doing things, okay? And for me, that's success. But a fluent IntelliJ user will do very different things and make good use of a lot of features that I just don't know a whole lot about. Alright, so I have a button called Go button. Let's go back to our activity, and let's click on this button, and let's look over here on the right, and there's an entry for on click. Okay, looking at this right here, and if I select the drop down menu, it gives me an option for activating the Go button method when this button is clicked. Alright. So that's set up now. When this app is running, if I click the Go button, it's going to come in here and execute this code. Okay. Now sometimes, for some reason, IntelliJ creates two tabs for the same program, right? And I don't know what the difference is, so I'm just closing one out. It's just one of those things. All right. So how do we know that we're inside this code? Well, let's print a message. So here's one way to print a message. There's a class called log, and I can say log dot, and I can specify what kind of message I want to write. For example, do I want to write an information message, a debug, an error message, a warning message, and so on. And the log method takes two arguments. The first is a tag, the second is a message. The tag is something we can filter on if we just want to restrict our messages to a particular type, and then the message is whatever we want. So I'm going to do a log dot, let's do a debug, and I'll just say, 223B will be my tag, and my message will be button has been clicked. Okay, we need to import the log class. And I'm going to go ahead and push all this over to my simulated phone. And down here there's a thing that says logcat. If I click on that, and I come over here and select my emulated pixel, right, and I say verbose, which means show me everything, then any messages that are being printed with this log call should show up down here. So if I click the Go button, I get a message here saying, 223B : button has been clicked. So this takes the place of doing like system out print line. Okay, it's a really quick way to toss some output into a place where you can read it. And this works if we're doing our phone also. So let me come up here and switch to, well, let's see. Actually, I'm going to unplug my phone and plug it back in. We'll see if we can get lucky. Okay, so it says allow USB debugging. I'm going to say allow. And I'm going to come back over here, and now this is switched to my phone, and I can say push this over to my phone. And if I look at my phone display, there's my application running. And I'm going to come back to my logcat window. I'm going to change this to say I want to look at log messages coming from my essential phone, right? And this is stuff that's, happening on my phone. But I'm going to come over here and hit the Go button, and there's my debug message saying the button has been clicked. These little smileys down here, you can use these to send feedback. So if you click the smiley face, it says, thanks for the feedback, we're glad to hear you're having a positive experience. And I'm guarantee that some people just come out here when they're getting lots of bugs and they just bang on this button like 200 times in a row. And I don't know what Google's doing with that information, but hopefully it's making someone laugh. Let's go back to our emulated phone. So we can connect code with events, right? We can say when this button is clicked, here's what I want to have happen. I want to run this Go button code. All right. Now, how is this working? So when we created JFrames under Window Builder, we had a little pair of tabs down here for design or code, right? So we could actually look at the source code, or we could look at the graphical view. Same thing here. This is the graphical layout. But up here, I can click on this little icon here, and this will actually show me the code. And this is not Java code. This is XML. Okay, XML, Extensible Markup Language. It's just a very generic way of describing hierarchical relationships among different pieces of data. So, so this whole thing is collections of stuff between an angle bracket and a slash angle bracket. Okay, so these delimit, in this case, a text view, which is set up with these properties. And these are saying, for example, where that view is constrained, Okay, so the bottom is constrained to the bottom of the parent, which was the main frame, and so on and so forth. The text was ha ha ha, and I can change this to, hello, and go back and look at my graphical layout, and you can see that that text field says hello. Okay, so these are basically two views of the same thing. Okay, we have a button which is called button, and there's an on-click field. Android : on-click is go button. That's what happened when we came over here and we selected the button, and we came down and we said, what should we do on a click? Let's call go button. Okay, that created this piece of code right here, this one line. There's the text field that's displayed, and so on. And this is all, part of a tag called Android X constraint layout, blah, blah, blah. And here's the ending tag. Okay, so you can monkey with this code a little bit, but don't go too intense on it, because there's very particular things that need to happen here. Okay, and if you break this, then this doesn't work anymore, and your app probably won't run successfully. All right, so let's play with a text field. Okay, so let me, this is a text view, and let me come over here. I don't know what that does. All right, let's rebuild everything. So I'm going to get rid of this text view because it doesn't have a name, and I don't know why it doesn't have a name. But I'm not going to try to figure it out. I'm just going to make a new text view. Okay, let's put a text view in here. And let's anchor it. I made it big, I didn't mean to do that. Alright, and we'll put it below the go button. And so I'm going to change its name to be message box. Alright, now what I want to do is when I hit the go button, I want to display some text inside this message box. Okay, inside this text view called message box. If I change the name of something else. This is another thing that happens sometimes. Maybe it's just me in Android Studio. I think I'm editing one thing, but I'm editing something else. Okay, so my text view, I want to change the name of that to message box. Alright, and you can see over here in your hierarchy, my main layout is called blah. My message box is the name of my text view. Okay, so I want to change the text inside here in response to the mouse click. So we need to get a hold of that object, that text view. Okay, so I'm going to make a placeholder for it. Here's text view MB. That's our message box. We'll import this class. So that should come from Android widget text view. And then when I call my so when I first run my application, this onCreate method is called. Okay, it's when your application is created, and it does the superclasses onCreate, and then it set content view basically causes this stuff to appear on the window. Okay, so I can do some more initialization in here. Get the text view object. So here's how I'm going to get a reference to that text view. I'm going to say message box equals, and I'm going to do the following: find view by ID. Okay, that's how I can get a hold of a widget. Okay, and I have to tell it what the object is that I'm trying to get a hold of, and I don't know its ID, but I'm going to say r.id dot, and I'm going to put in the name, which in this case is message box. Okay, this is a symbol for this number, and that number corresponds to that particular object, but I don't want to hardwire a magic number, so I'm just going to do message box. And once I do this, MB should be that text view that's currently saying hello. So in my go button method, all I'm going to do is the following: mb.setText, and I'll just change the text to say click. So let's go ahead and dump that onto our emulator. And there's the go button, and the text view is just saying text view. And when I click the go button, the text view changes to the word click. And here's something to note: if I exit from this app and I rerun it, my text view still says click. Right? Exiting and running does not restart the program. Okay, that's not how the life cycle of apps works. Now if I come in here where I look at all of my apps and I swipe that thing up to get rid of it, and then I click on my app, that basically restarts it. It recreates it, which means the text view is set to its default value, which right now is just text view. Okay, so that's that life cycle stuff. All right, so we can start doing stuff that we know how to do in Java. Right, like we could change our text field to say I equals and show the value of this integer I, and then we could increment I. And now I've got something where every time I hit a button, it counts up. Okay, that's not terribly exciting in itself, but it should have your brains thinking, hey, I can do anything now, right? That's really all we need to be able to do pretty much anything. Because now we can connect events to code. All right, so let's hook up some more events. So let's pick up a touch event. So I'm going to do the following. I'm going to say public boolean on touch event. Alright, so I have to import this. And this is basically making, like a mouse listener. When we touch the display, this code's going to get executed. So let's use our text box, our message box. And let's print our x coordinates from the motion event, me.getX. Like that. Not sure why it doesn't like that closing bracket. Oh, and it's a boolean. It's got to do a return. And I'm just going to return true. You can basically return to say whether you handled that event or not. And I think if you return false, then it gets passed on to other things that might be listening for touch events. So I'm just going to return true. Let's put that onto our device. And so, I can click here and I can count as usual. But if I click anywhere else, my text field changes to show me my x and y coordinates. I didn't make a lot of space for my x and y coordinates. So let's make this text view bigger. That looks good. And let's dump that on there. So rapid prototyping here, right? making these changes, and they're going in pretty quickly. So there's my XY coordinates. And if I hold down the mouse and move, it continually updates. Those are all generating on touch events, or touch events. And 0, 0 is actually way up here in the upper left corner of the screen. Okay, it's not just this visible area down here. All of this is generating touch events. But if I click up here, something else is picking that up. That's where I can get to my settings and such. But if I click down here and I go up there, I'm still picking those up. So there's a whole hierarchy of who's picking up events and what are they doing with it, and so on and so forth. So we can interact with the mouse or the finger. Man, time is going quickly here. Let's get rid of all of this stuff. Let's see if we have time to do some drawing. So I'm going to take a view and drop it into here. And it's just called view. And I'm going to create a new Java class. Okay, I'll do it under Java. Let's do a new Java class. So what we're going to do is we're going to create our own view that we can basically override the paint method on to do some drawing. Okay, so I'll make a view called my view, and I'll say that extends view. And I need to define a constructor. Okay, so this is telling me there's no default constructor for a view, so I can't just defer to the parent class. So I'm going to make an explicit constructor which says the following: public my view. It's called with an argument of type context. And all I'm going to do is call the superclass with that context. Let's import that. Alright. And then I'm going to make the equivalent of a public void paint. So for Android it's called onDraw. And instead of taking a graphics argument, it takes an argument of type canvas. Like that. So we'll import a canvas. And I'm going to do the following. I'm going to say canvas.draw a circle, and let's just draw a circle at 300 with a radius of 50. And then we need to specify what paintbrush we want to use. So I'm going to do a paint, and we have to define what paint is. So let's do paint. And I don't know what the default color is, so I'm going to set the color. Paint.setColor. Let's do color.red. Alright, so when the canvas is drawn, we'll create a paintbrush, we'll set the color to red, and then we'll draw a circle at 300 with a radius of, let's go with a radius of 100. Okay, this is the onDraw method. That's the equivalent of the paint method. Okay, and this is for a thing called my view. Let's go back to our main activity, right, and this thing is a view. Let's look at the XML. So that's a view. Our main activity, I'm going to get rid of all of this stuff. I'm going to get rid of this stuff. Get rid of that. And then I'm going to make one change in here. So when we create the application, instead of setting the content based on this activity main XML, I'm going to just set this to a my view. Okay, so I'm going to construct a my view, and I'm going to pass it this, which is, you know, the context of the main activity, which will get passed to the superclass's constructor. And then whenever my view is being drawn, the system should call its onDraw method, which should make me a red paintbrush and draw a circle. So let's dump this onto the device. And bingo, there's our red circle. So these are all kind of analogous to what we've been doing with Swing and Window Builder, right? When we want to force a call to paint, we call the repaint method in Swing. In Android, when we want to force a call to the onDraw method, we call invalidate. So if I have a my view and I say, you know, my view.invalidate, that'll force a call to this onDraw method. So if I change my underlying data structure, I change my array of dots, for example, and I want to display it, I could say invalidate, and that'll force this to be called, and it'll go ahead and do my painting. So if you wanted to take your dots program and port it to Android, it's fairly straightforward, right? There's plug-in replacements for, you know, how we connect buttons to events, how we do painting, how we force a call to paint, and so on and so forth. So that's a little bit of what I wanted to get through. I ran out of time, unfortunately. But you know, that gives you the basics. You can pick up touch events. What we did not talk about was, you know, all the goodies inside an Android phone. The fact that there's a GPS and there's a SMS subsystem and accelerometers and all this kind of stuff, and we can tap into those, right? The documentation is pretty good. It's like the Java doc we've been looking up all quarter. You can go to developer Android.com and find, you know, details on all of these different classes and packages, and this gives you a framework to basically do your development and debugging and trial and error from. Okay, so hopefully that helps. We're out of time, but if you got any questions or comments, right, catch me in office hours or something, and we can talk more about this. Otherwise, have a great afternoon. I will see you tomorrow.